Okay, well, hello and happy Monday. And today we will take a look at some basics of Git. And again, just to kind of reiterate, make sure do your data camp homework, and your data camp homework should give you at least an introduction to some of these ideas and concepts, working with shell, working with kind of the command line, and then also working with Git. And I'm going to be interacting with Git mostly from the command line, using the command line interface. And I know Git also has kind of a graphical interface that's pretty nice, but the command line you can always kind of trust to work. And sometimes you have to SSH into you have to kind of log into a remote server, and the only tool you're going to have really is going to be the command line. So it's worth learning how to work with the command line. There are, and at least for some of these basic things, the difference between Windows and Mac and Linux and these Unix-based systems are, the differences are small enough that we can still work through a lot of these things. I guess the prerequisite is you need to have Git installed on your machine, and if not, there's a few ways to do it. But yeah, let's go ahead and just take a quick look, and we'll introduce some of the stuff. All right. So what's Git in the first place? Git is a version control system. And there's lots of different version control systems out there. And if you work for any kind of semi-big company, they will likely have some version control system that you're going to have to use. A lot of them use Git, okay? But that's not to say there other ones exist, right? I think Facebook developed their own version control system or something. I don't know. But a lot of it is kind of based on the idea that any kind of changes that you make are being tracked, and you can always kind of roll back to an older version, right? And so, because the classical method of version control, the rudimentary method is just you write, essay, rough draft, essay final draft, essay final draft, essay final draft. This is the one. Essay final draft. I submitted this one, or something right like that, right? And you have all of these things, and then you can kind of, if you need to go back and say what did I write before or something, you can kind of find it that way, right? And so Git basically does a better job of this. Okay. Also, it allows for synchronization and collaboration, so that multiple people can be working on the same project and same set of files, and I will try to get these things to work out. Okay, so the most important commands are really just these. I would say these three commands, right? Git status. You should, when you're getting started and you're new to Git, always type in Git status. Okay, there's nothing. Just get in the habit of after you do everything, type in Git status. Okay, and then you'll by typing in Git status after every single command, you'll start to understand what is happening. Okay, if you read through it, okay, you'll start to understand what each of these things do whenever I run one of these commands. Okay. And then after a while, after you feel comfortable with all of this, then you can stop writing Git status. But it's always good to check your status. Okay. There are the process of making a change. Okay, is you stage the file. Okay, so you'll do git add, and you put in the name of your file. Okay, so you wrote git add filename.txt, and that's going to take whatever this file is and put it in the staging area, and then after you stage it, you commit it. Okay, and you do git commit. Okay, and that's going to commit these things. So what is this? How is this different from just clicking save or something like that? Okay, I'll talk about all of this. Okay, If you have a whole bunch of changes, you can do git add dot, and that will just change everything in your current kind of working directory. It'll stage everything. And then when you commit, you always have to include a description of the commit, okay? And so this command commits the changes in the staging area to the repository. And now that change is forever kind of like written down in history, and you can always kind of go back to whatever, this current version of the file once you have it committed, okay? And so normally, without a version control system, without Git, the way you work is you just have your directory, you create files, you make changes, you save them, and they're just there. And if you delete something, it's kind of gone forever. Once you click save on a file and you close it, like that's it. You can't undo something, right? So the nightmare scenario is, you accidentally delete a huge portion of your essay, and then you accidentally hit save, Control S, because it's like such a simple thing. And then once you do that and you close it, like there's no going back, right? It's kind of like, I don't know, like in video games, like there's like a quick save, right? And if you accidentally hit quick save, like in a bad position, like you're stuck, and like now your save file is like, oh gosh, like now I'm always stuck in this kind of thing, right? So with Git is beyond just kind of regular saving and stuff in your working directory. We say, you know what? Basically, take a snapshot of what my file folders look like at this location in history, and now we have like this time machine where we can always kind of go back to this point in time, and that's kind of like, I guess, yeah, like if you think about video games, you can always, like if you create manual saves after like key locations, even if you mess something up later and you mess up your save file, you can always kind of go back to this key location in time and start over from there or something like that, right? And so to do that, there's a couple things, is you do git add and you do git commit. So why do we have two separate things? Okay, why do we have to do git add and git commit? Why can't we just do like git, freeze time right here? Okay. Well, a lot of, did I put a slide? Okay, yeah, here. Okay. When we do commits to a repository, what we want to do is we want to have logical and small changes that are easily understood. Right? So when you have kind of this flow of commits, you want each of these changes that we've committed to make sense. And our workflow, however, doesn't always reflect this kind of logical progression. And a lot of times you might be making changes to multiple files all at once. And you don't want to just say commit all of the changes all at once in kind of one commit, okay? You might want to break them out, and you might want to say, okay, this one I'm changing the report, and we will have a separate commit for changes to the report. We're going to have this one I'm making changes to the data file, this one I'm making changes to the script, and you might want to have separate these commits so that if you want to roll back in time, you can kind of roll back to, pull out the change to only the report, or pull out the change only to the script or the data file or something like that, right? So if you've been working on several files, you can break those up by adding only one or two of those files at a time and then committing just those changes, okay? And all of those changes are going to be tracked, and you can always kind of look up the history of your commits in the Git log. So other kind of important things is Git log, and this will kind of show you the entire timeline of your repository, and this can be a very long thing. And so if you have multiple pages, you hit space to kind of go to the next page. Anytime you want to kind of quit out of the log, you just hit Q. Okay, you type in Q to quit out of the log, and that'll take you back to the command line. And if you want to, if you find the kind of the version of the file that you want, you can identify that, and you can check out certain files from that thing. Okay, so it's kind of like this library of time machine, right? So you can kind of roll back time, and then you can pull out, from this library, you can check out versions of that file, right? And if you like this older version, you can then you can commit that older version to your repository. Okay, and so you can say, so in the log, the way it kind of all of these locations in history have what's known as a hash. Okay, and the hash is a way to kind of identify this point in time. So if your hash is AB123EF, you're going to do get checkout and then say the name of the hash or the name of your commit, and then you pull out whichever particular file name you want from there. Okay. If this is the first time you've ever been exposed to Git, this is just going to sound like gibberish, and it might not make sense right now. Okay, and again, just like everything else in life, the more you kind of work with it, and the more you're exposed to it, the better you're gonna get. I guess all I can do is kind of force you to use Git a little bit, and I hope you'll find it to be a worthwhile thing, especially in the in the future in your career. I think it'll be a useful thing. Okay, you can take a look at what changes happen to be made to a commit. All right, and so you can say git show, and then you type in the name of the hash associated with a certain commit. Okay, and so usually the hashes are like, I don't know, 50 character long or something. This is very long, kind of this thing of letters and numbers, and you only have to type in like the first 6 letters or 5 letters or something like that. Okay, and so when you do this, Git is going to show information about the commit, and it'll tell you like who did it, the time it happened, and in any kind of comments here, right? And if you're working by yourself, you're going to be the only author, but if you're working with multiple people, then you can it'll tell you exactly who made that particular commit, and then it will tell you, you'll see the file name, and it will be you have A versus B. A is the file before the change or before the commit, and B is going to be the file after the commit. And then what you'll see is okay, at line 23, okay, the changes start at line 23 in the file, right? So you imagine your file being a bunch of kind of text lines, and it'll say, okay, starting at line 23, and then it's going to say what I'm printing here are the next 4 lines, and then in the file after, okay, starting at line 23, we're going to look at 5 lines. Okay, if there was no change to the file, those lines appear in white. Generally, lines that have been removed will start with a minus sign right in front of it. Okay, and a lot of times it will be colored in red to indicate that this particular line was deleted, and then a plus indicates that this line was added. So if you even if you just like add one word to a line, okay, Git won't show it as you just added this one word. It's going to say you removed this line and then you added a new line. So if the previous sentence was like, hello, my name is Miles, and then I replace it with hello, my name is Miles Chen, then it's going to say we removed hello, my name is Miles, and we replaced it, we added hello, my name is Miles Chen, even though it's just adding one word type of thing. So that's what we're going to see. Okay, so I want to kind of show you how to use Git and also how to use GitHub. Okay, so GitHub and Git are not the same thing, okay? GitHub is a separate company that hosts a bunch of what we call remote repositories. It acts as kind of like this, there's like servers that our computers can then kind of talk to, and that remote repository uses Git. So you have Git on your own local machine, and you can use Git entirely self-contained in your local machine, but like if somebody steals your laptop, or you spill soda on it and it damages everything, then it's all lost, okay? So to kind of protect against that, you can synchronize your local computer repositories with a remote repository, and therefore if something happens to your local computer, you can log in on a different computer and then find that remote repository. And as long as like the remote computers, right? So these remote repositories, these are just basically computers in these like server farms and stuff. And as long as like those things haven't like burned down, then you can access it, right? So sometimes that does happen though. Generally, like large companies like GitHub will have multiple copies of this in like different physical locations, different things, and like the locations of these server farms are like secrets and stuff like that. So usually once you kind of upload it to the cloud, it should be pretty safe, okay? There's a bunch of other similar services. There's GitLab, Bitbucket, I don't know, a bunch of other things kind of pop up. GitHub remains very popular. I think it got bought by Microsoft recently, and Microsoft, now supports a lot of kind of open source initiatives and things like that. And GitHub serves as a central location for a lot of these open source projects and a lot of kind of collaboration things. Now, you're not required, well, okay, for this class you're required, okay? But in life, you're not required to use GitHub for a remote repository, and you can actually set up your own remote repository, like you can set up your own server that runs Git and things like that. But GitHub really makes it easy. And there's a few ways to set up a repository, and one is you can create it on your local machine and then push it to GitHub, okay? But what I recommend is creating the thing on GitHub first and then cloning it to your local machine. And I'm going to show you how to do this, okay? So first thing first. So, okay, I've got a couple things going on, and I want to show you. So over here on this window, Smiles Chen, this is my account, and this is me as the professor, okay? And over here, I'm going to log into GitHub. I have a second GitHub account, and I'm going to sign in with this, and my account here is Miles Chen Student, okay? And so this is a picture of me when I was a student. I look like I'm 12, but I'm like 19 here, okay? So, some of you know the pain of like looking like a small child, even though you're a fully grown adult. And so anyway, this is me as a student, and so I'm going to pretend I'm you, the student, and we're going to do stuff like this, right? So you create a GitHub account, and so I think I deleted everything, okay? And so, if you create a GitHub account, it's probably going to be like very empty. There's like nothing, no repositories, nothing like this. Or maybe you already have a GitHub account and you already have repositories or things like that. But for a lot of you, you create a this might be your first time. And so here, basically, you just click sign up, and then you fill out, oh, okay, there's all of it. Okay, well, I don't. They updated this. I don't know what's going on here, but you go through that. So let me go ahead and just sign in. Go ahead and you create your GitHub account, and this is what it looks like. Now you can just create a new repository and things like that. You just you click this button that says Recent Repositories New or something, and that will create a new repository. But one thing we need to do is we need to be able to get our computer to talk to GitHub using SSH commands and things like that. So let's see. Okay, well, let's see, whatever. Okay, first we're going to have to create an SSH key on our local machine, and then we're going to add this SSH key to the GitHub account. So this basically has this secret key, secret password that we tell GitHub. This is a computer you can trust. And now, and then if our computer has the password or the key, then our computer can talk to our GitHub account. Okay. Otherwise, if you don't set that up, GitHub's not going to allow you to make changes to your repositories or accounts because it says, I don't know who you are. And you certainly don't want random strangers out there on the internet messing with your GitHub account. So you have to kind of set that up. Okay. So on my computer, I'm going to run a separate kind of virtual machine here. And this is, here I'm running some Linux. Okay. So right now here I'm just in my kind of home directory, and I have absolutely nothing here. And so if I type in ls, there's nothing. Okay. But one thing I want to do is I'm going to create an SSH key on my computer. All right. And so to do this, I'm going to use this command ssh keygen. All right. And so this is going to create an SSH key. So I'm going to type in SSH -keygen, okay, -t ed 25519. All right, and this is just to kind of, there's like different authentication methods, but just you can just type this in, and then what is the email address associated with your GitHub account? So make sure you use the correct one. So my student account is mileschen@ucla.edu. That's what I have over here for Miles Chen student. Okay. Let me go to settings. Well, I don't. Okay. Well, I don't know where it is. All right. But so on my GitHub account, what I'm then going to do is I'm going to open up settings. Okay, under my account here, I'm going to open up settings, and I'm going to go over to, on the left-hand side under access, I'm going to choose SSH keys, SSH and GPG keys. All right. And right now I have no SSH keys associated with my account. Okay, but over here, I run that command SSH keygen, and I hit enter, and it says we're generating a public-private key pair. All right, enter the file in which to save the key, and it's going to default to say it's going to store it on my my Linux system. It's going to store it in the folder .ssh. in the file id underscore ed 25519. Okay, and that address is fine, that location is fine. So I'm just going to go ahead and hit enter, and it says enter a passphrase. Okay, I recommend leaving this empty and not putting in a passphrase when you generate an SSH keygen. Okay, so I'm just going to leave it empty. Now that's assuming your laptop is your own laptop, it's not a shared laptop, and that you at least have a password when you initially start up your laptop, right? So that like if it does get stolen or something like that, then somebody doesn't have access to everything on your thing. So there's an assumption that you at least have some locks on your thing. Okay. Now if you've already done this or something and then you created a passphrase and then like you regret creating a passphrase, what you'll have to do is you'll have to delete your currently existing SSH key. Okay, so anyway, this creates a thing, and it says here's your fingerprint and whatnot, and the key is now located in my .ssh folder. Now if I type in ls, there's still nothing there. So and that's because by default Unix and Linux and things don't show folders that are preceded with a dot. So I just do ls-a, and it lists off like my hidden folders, and I can change into my change directories into my .ssh folder. Okay, and now if I type in ls, I have two files. One is my secret key, and then the other one is the is the public key. All right, and so what I need to do is I need to add my public key to SSH. Right. So again, I'm in my student account here. I'm under settings, SSH keys, and I'm going to click, I want to add a new SSH key. And then the title, I would name whatever computer you're using. All right, so this is going to be laptop, and for me, this is kind of my my Linux VM. Okay, and I'm going to now copy the public SSH key into here. Right, and so to do that, to get the contents of it, I'm going to just do cat ID underscore ID ed 255, and then I want the public. Okay, so .pub. So I name this. So this is my public SSH key. I'm going to go ahead and copy this. So I just, Control C it, and then I Control V over here, right? And so now I'm copying the public SSH key that from the system that was generated, and I'm going to put this in here. All right, so I'm going to click Add SSH key, and so now I have an SSH key added to my system here. All right. Is this okay? Kind of, you can always rewatch this video to see what happened. Okay, and then and so now we have that, and this is now added to my GitHub account. Okay, so this is kind of I guess instructions on how to do that. All right, so now let's go ahead and create a repository. So I'm going to go back to GitHub, and I'm going to create a new repository, and I'm going to just call this class demo as my repository, and this will just be class demonstration repository. That's fine, and we'll make it public. I'll go ahead and add a README file, and I'll go ahead and create a repository here. Okay, so this is now the repository. Okay, and I have one file in here, and this is just a markdown file. And it just contains basically this text, but that's enough to kind of create this. So what I want to do, so this, I've created a repository on GitHub. And again, to do this, I'm not going to do it again, but from GitHub, you just click the new repository button. Under recent repositories, you click new, you type in the name of your repository, and then you create one. Okay, so once I've created it, this is what it looks like. Okay. And now I'm going to clone from GitHub down to my computer. So as far as cloning, I'm going to use the SSH, okay, to clone it. Now, if you use HTTPS, then the authentication is done kind of via the browser and whatnot. We're going to go ahead and use SSH because that's what we created. So I'm going to copy this address, all right? And we're going to clone this. Okay. So on my local machine, I'm going to type in git clone, and I'm going to paste the address that I copied. Okay. So I type in git clone, and under code, this is the address that you copy. All right. So here it says we're going to clone this, and I'm going to hit enter. All right. And this is because this is the first time I'm using my SSH thing. It says, are you sure you want to do this? And I'm going to go and type in yes. And I believe I have, oh, darn it. I cloned this in the wrong location because I'm in my s.ssh folder. Okay, so I need to I'm gonna, I gotta delete this. All right, so sorry. All right, so let me go to class demo, and we're gonna remove readme.md, and then I gotta get into my Git. Oh gosh. All right. Actually, this is a bit of a pain, but I need to delete. I forgot how to delete directories with contents in them. Okay. Anyway, I cloned it in the wrong location. I'm gonna have to delete this. Delete it later. Sorry, I have to get. So sorry. Okay. Let me just go back to my home directory. Sorry. So cd tilde will take me back to my home directory, and I have nothing in there. Let me just redo this whole thing again. Okay. I'm gonna git clone it into my home directory. Sorry. So git clone, and I'm cloning this into my home directory. And now that because I've used the key before, I can now clone it here, and there's no issues. Okay. So it has cloned everything into here, and so now if I do ls, now I have the class demo in my home directory. Okay, so I can change into class demo, and I can see the contents of that directory, right? And here, because this is a Git repository, I can type in git status, and it says on branch main, your branch is up to date with origin main. Nothing to commit, working, tree clean. Okay, so sorry. Make sure when you clone a directory, you're in the proper location where you want that directory created. Okay, I'll have to clean this up a little bit later. So, but it's fine. I have like this thing located in a couple locations. So let's try creating files, and then committing them, and then pushing them to my remote repository. All right. So there's a simple text editor called Nano, and I'm going to create just file1.txt, and this is going to create a file called file1, and this is Nano, and here we'll say this is a simple text file. Okay. And then I'm going to save this. All right. To save in Nano, you hit Control O, and it says write out. And where do you want to write it? File1.txt. I'm going to go ahead and hit Enter. And then to quit, I hit Control X for exit. Okay, Control X, and that quits. All right. So now if I type in ls to see the contents of my folder, I have file1.txt and readme.md. Okay. And I can ask git status. And it says we have an untracked file, file1.txt. So I'm going to go ahead and I'm going to stage it by doing git add, and then I'm going to commit this to my repository. Okay. So if I do git add, I'm going to do git add file1.txt. All right. And if I type in git status now it says we have a new file, and these are changes ready to be committed. Okay, and then there's always kind of the git status actually gives you a lot of kind of helpful information. It says, you know, up here when I said git status, and it says here's an untracked file, and it says use git add file to include in what to be committed. And then it says if you want to unstage, you can do git restore -- staged and then file. And I think in DataCamp it says git reset, and git reset's like another way to kind of unstage files and stuff. But here we have this, and we'll go ahead and we'll commit it. Okay, so I'm going to do git commit -m. You always have to add a message. The -m is for what message to be associated with the commit. And so I'll say added, or maybe I'll do created file1.txt. Okay. Your email name and email address were configured automatically based on your username and hostname. Okay, that's fine. Okay. Yeah, if it's your very first time using GitHub, all right. So anytime you see messages on Git, they're usually pretty helpful, and I would recommend reading them. And if you can't understand it, you can always kind of just go on the internet and just type in the message that you received exactly, and people will say like, what does this thing mean? And that'll be a pretty good interpretation. Okay, but one thing is you can kind of configure your identity and whatnot. Okay, so anyway, here I have this, and now I can do git status, and we can see this is fine. It says your branch is ahead of origin main by 1 commit, and you can push to publish your local commits. I can also type in git log, and here is my log. Here's kind of the initial commit. Here's kind of my most recent thing. I can do git show, and I can type in the hash of the first few letters of my hash here. And here it says, okay, created this, and basically it started off, and we just added this one line of text here. All right, so here, so basically our picture right now, as I've made some changes, we saved it, we did the add, we did the commit, and now this is my local repository. I want to push the changes in my local repository to my remote repository, right? So, whoops, right now on the internet, GitHub has no idea that I've done anything to my repository. And so I'm going to push this commit. I'm going to do git push, and it's going to push the changes from my local computer onto the internet. And so if I refresh my repository on the internet, we can see file 1 has now been added, okay? And so there it is, okay? This is a simple text file, okay? And so I can do more, right? So I can, let's open up file1.txt again, all right? All right, so I'm gonna just list off colors of the rainbow, okay? Just for fun, all right? So we're gonna do, what are the colors? We got red, orange, yellow, green. Okay, so we'll save that there, all right? We're gonna Control O to save it, and then Control X to exit, okay? And if I type in git status, it's gonna say, oh, we've modified file 1, all right? So let's go ahead and we'll do git add. You can also do git add dot, and that's going to add all changes that exist in your directory. And then I'm going to go ahead git commit -m, and we'll say added a few colors to file1.txt. You can suppress this message by setting them explicitly. Oh, you know what? Okay, so this message keeps popping up. That's fine. All right, and here, let me just do git config user email and username. And I think getting started, first time git setup, I think git config -- global username. So I'll go ahead and do this. All right, so I'm going to do git config -- global, and then my username will be Miles Chen, and then git config -- global user.email is mileschen@ucla.edu. All right, and this will prevent this message from popping up. Oh, I didn't put quotes around it, but I think, well, maybe it doesn't matter. Okay, so let me go ahead. So I've committed that change. So I'll check git status, and then I'll go ahead and push this. All right, and so now if I refresh this, we can see file1.txt now has the updated stuff. And then you can also, on GitHub, you can click history, and you can see, all right, this is the first file that we created, and then this is kind of, these are the things that we've done, right? It says you added these lines to the thing. And again, over here, we can do git log. We can see all of these changes. and I can say show what happened in this most recent commit, 2B18233. All right, and oh, I forgot git. I'm like, what's going on? Okay, so git show, and it says, okay, this is what happened in that commit. Okay. All right. Let's say we want to make some changes here. So let's say somebody else made a change, right? So I'm gonna here I can just do file one, and so you can actually edit some of these things. All right. So we're gonna just do red, orange, yellow, green, blue, 6, indigo, 7. All right, violet. Okay. And so I'm going to just kind of make changes in my browser here, and we'll say added 3 more colors, and then we'll go ahead and click commit changes. All right, so now I've modified the changes over here, and so we could pretend like something happened, and so now my repository now has even more stuff in it. Okay, now if I come over to here and I say, show me what's the contents of file 1, it doesn't have anything, right? But and if I do git status, it doesn't know anything. Okay, so my computer doesn't. It's not like my computer's constantly pinging GitHub to ask what's updated. But if we are aware that some things have happened, we can do git pull. Okay, and this will pull things from the remote repository into my local thing. Right, so I type in git pull, and it says, oh, you know what? We noticed some stuff, and we're adding some lines here. And so now if I do if I say what's in the contents of file 1, it now has the updated stuff here. Okay, so this is kind of how we're committing stuff. Have I given you any view quiz answers yet? I've totally forgotten. Oh my gosh. Okay, the first 2 ones are the letter C. C as in cat. C and C. I'll give you your third one too. It's E. Okay, C, C, E are your 3 view quiz answers. Cat, cat, elephant. Cat, cat, elephant. C, C, E. I really hope. Cat, cat, elephant are your view quiz answers for today. Okay. So let me explain how I'm going to publish things for this class website and for the course. Okay. So on GitHub, what you'll have to do is you'll have to go. You'll have to find my you'll have to find my repository for the class. Okay. So my GitHub is github.com/smileschen, and I got 2022 fall stats 21. Okay, so I'm gonna open this up, and right now there's basically these things. So what you want to do while you're logged into your account, you're going to want to fork my repository. Okay, and this will fork it into basically create a copy of this into your account. I'm going to click fork, and it says create a new fork, and I'm going to create it into my student account. I'm going to just leave the repository name, the fine, and we're just going to copy the main branch, and that's fine. Okay, so we're going to create a fork, and we're going to copy this. Okay, and now that I have forked this, I want to clone the fork onto my local computer. So here, let me change back to my home directory. I'm going to do cd tilde. This takes me back to my home directory. And I'm going to clone my fork. Okay, so you can't clone mine. Okay, because, oh no, this is not mine. So my account, the Smiles chain, you can't clone this directly, okay? Because it's expecting my key, right? It's not going to let you mess with my GitHub repository, okay? But you can clone it or fork it as a student, and then once you have it on your thing, you can clone it, right? So you're going to copy this under code. You're going to clone SSH, and again, in your home directory, you're going to type in git clone and paste that thing, all right? So now it clones this thing, right? And let's change directories into 22 that, 2022 that, and here are the files, and it's got the two files, lecture1.pdf, 1-1 getbasics.pdf, and you'll be able to find this in your Finder and open it up and stuff like that, okay? As the course goes on, the professor, I'm going to update things, and I'm going to upload additional stuff. So let me simulate that. All right, so here. All right, so I'm going to just do nano file1.txt. All right, so this is demo file update. Okay, git status, so we'll git add file1, git commit -m, add file1.txt, and we'll do git push. Okay, so now the professor's thing now reflects file1, okay? But your student thing still has this, and it doesn't have anything. So what we need to do is we need to tell your computer to fetch changes to what we call an upstream repository, right? So it's like, I'm the professor, and I'm creating stuff, at the top of the river, okay? And my changes flow down, and what you need to do is you need to catch those, and you need to kind of update your repository as such, okay? So in order to do that, we have to configure, you have to configure what we call additional remote repositories. So right now, you will have the origin, your origin repository will be your GitHub name, okay? And then, this one says winter, but it'll say fall. But what you need to do is you need to configure an upstream repository. So to do this, you're gonna, from my page, you're gonna copy this address, okay, for the Smiles chain, the professor's account, okay, and you're going to use this command, git remote add an upstream, okay. So here, so if I do git remote add, here, git remote -v currently just shows an origin for fetch and push. We're going to do git remote add upstream. Sorry for the delay for being here. And I'm going to add, this one will have Smiles Chen in it, okay? And we're going to add the professor's account here, okay? And so now once I've added that remote stream, if I do git remote -v to kind of get our current configuration, we have both the origin and the upstream things, okay? And now to kind of currently, my directory doesn't have that new file. So what you want to do is you want to be able to pull changes from my from the professor's account. So you're going to do git pull, and you want to pull changes from the upstream repository. So you're going to say git pull upstream main, all right, the main branch on the upstream repository. And when you do this, it's going to say, oh, you know what? We located a new file, file1, okay? And so if I do ls now, we can see file1 is here, okay? But your account, if you refresh this, still doesn't contain file1. So what do? you have to, so the way it works is the upstream, you pulled this into your local thing, and now you're going to push those to your repository. So you're going to do git push, and it's going to push the that file1 over to the remote repository that belongs to you. And now you can see file1 has been added here. Okay, and so I'm going to continue kind of uploading stuff to my GitHub, and then the way you're going to retrieve them, and it'll take a little bit of getting used to, but you're going to retrieve them by just typing in git pull upstream main, and it's going to pull all of the new content, and then and if you want to kind of push it to yours, you can do that. And I think once you get the hang of it, you'll realize, this is a superior method for getting updated files rather than having to individually download all of the files from Canvas or something like that. You just do git pull, and it's like if I uploaded 20 files, all of them will get pulled immediately in kind of one command, which is nice. Okay, thanks for sticking around. We'll see you guys on Wednesday.
Thank you.